In the last lecture, we talked about how good the models were for predicting climate change. Now, most of us are concerned about the impact of climate change, how it affects our life. And some people may be concerned about abrupt climate change. What is abrupt climate change? Climate change which occurs more rapidly than what you are used to. Okay? And so these are of concern. So people have looked at how climate change occurred abruptly in the past. We talked about it earlier in this course when we talked about the Younger Dryas event near Greenland, as well as the Berlin-Arroyoid events, which occurred due to melting of the Greenland ice sheet. So a lot of books have come out talking about angry weather, okay? Heat waves, floods, storms, and because people are concerned about climate change. So in today's lecture, we will talk about what evidence is there about the impact of climate change. Okay? Now you must remember that our ability to understand the impact of climate change on extreme cold and extreme heat is quite good. Already I discussed the probability distribution, which shifts to the right. So we understand that quite well, and our models also predict that quite well. So this is understanding is high, attribution about what will happen is also good. So these are things which can be predicted quite well, and we can prepare for it. Okay? So what is called adaptation. So we know that there are going to be more and more extreme events, then we can plan accordingly. Okay? But the next one which we are all interested in India are droughts and floods due to extreme rainfall. These are not as well understood as these. Okay? These are local phenomena, and the models are not able to simulate them as accurately. And our confidence to attribute any one drought or flood to increase in carbon dioxide is not that good. Okay? Then you come to tropical cyclones, wildfires, severe thunderstorm or convective storms, extreme snow events. These are much more difficult. Okay? These are events of very short time scale on a very regional scale. Our understanding is not as good, and our confidence in attributing this to an increased carbon is not that good. So you must remember that we have limitations in attributing wildfires, changes in tropical cyclones to CO2 very well when compared to extreme heat and extreme cold. So you must remember that there are many kinds of climate impact, and only some of them we have great confidence, and some we don't have. So it's important to differentiate between which kind of events we are confident, which we are not, okay, so that we can be prepared for the future. Now let's look at how these impacts affect our life. So here is a documentation mainly from insurance companies. They have said over the last 20 years, about 1.6 billion people were affected by floods. Okay? About 1.43 by drought. So these are major events which we cannot predict accurately. Long term, we can predict what will happen next week, but not next year or next decade. Severe thunderstorm also affects almost 700 million people. Compared to the earthquake, which many people are worried about, affects much smaller number of people because it only occurs in certain parts of the world which are controlled by plate tectonic movements. Okay? And of course, extreme temperature, volcanoes, landslide affect about 100 million people in the last 20 years. And extreme temperature we can predict fairly well. So, we can adapt to this much more easily than to these. Okay. So, that is the message about impact of climate change. Now, insurance companies like Munich Re have documented, because they have to pay insurance damage to many people and countries. So, they have shown that the number of natural catastrophes has increased from around 100 per year in 1980 to close to 300 to 350 by 2010. So, a factor of 3 increase in just 30 years. And so, we will have to expect this to increase more rapidly in the future as the impact of climate change becomes worse and worse. Okay. Now, I want to look at various things. There are hydrological, which dominates, then storms, meteorological, and you can see that geophysical event like earthquake, volcanic eruption, they do not change much, okay, because they are not controlled by temperature. So, volcanic eruption, earthquake are not connected to climate. So, CO2 increase will not change the number of earthquakes or tsunamis or volcanic eruption, because they are governed by completely different physical parameters. Now, which countries are most affected by the extreme weather events we talked about? All of you must be aware of it. It is mainly India and China, because you have a large population, you have a high population density, and we are influenced by droughts, floods, and extreme temperatures. Okay. So, in comparison to that, the other countries have much lesser impact. Now, to understand the role of the impact of climate change, you must remember that the distribution of temperature in blue here, which is the distribution in the past, and the red is the shift in the distribution to the right on account of global warming. That I discussed earlier, which is the most fundamental shift in the distribution temperature from left to right as global warming has occurred, but this is not the only change. In addition to the shift, there is also change in the variance. Variance change means the distribution becomes fatter, higher variability. Okay? So, even if the mean does not change, there is a change in variability. In reality, both these occur together, and so in reality you have this kind of change where the original distribution is both shifted to the right and also it enlarges in the variance. Okay? So, that is why you are getting many more heat waves as shown in this graph as compared to the past. Okay? Most countries are experiencing many more heat waves now than in the past, because the mean has shifted and the variance is also shifted. This is shown in more detail in the graph on the left. You can look at it in more detail. This is a simplified graph. This is a more graph with more explanations there. Now, the problem is there is long-term global warming, there is natural climate variability on a year-to-year and a decadal scale, which we cannot control, which we have to adapt to. Both these combine and give you the present change. Okay? So, it is important for us to differentiate between natural climate variability and climate change, because climate change is something we can control by reducing CO2 emission, while natural climate variability cannot be controlled. We have to learn to live with that variability. We have to learn to adapt to it. We have to learn to find ways to handle natural climate variation, which has occurred for the last 10,000 years, and human beings have largely adapted. Today our ability to adapt has gone down mainly because our population has gone up from less than a billion to 8 billion. Okay? There are more people living in areas with large population density. In the past, when climate variability occurred, people just migrated to some newer place. Suppose there was a drought in a part of Karnataka, the population moved to another part where the drought was not there, and then when the variability changed again, they moved back to this place. This has been a tradition in India for past 1,000 years. It is recorded in historical anecdotes. Okay? But today that is not an option. Today our population has gone beyond 1.4 billion, so large shift or migration in the population is not possible. So that is the challenge we face, that today whenever there is a drought or a flood, large scale shifting of population is not feasible. Now let us look at a few examples of extreme events like heat waves, and let us see how they are changing. Okay? Now heat waves can occur due to large scale climate variability like what is called El Nino Southern Oscillation, the warming in the Pacific Ocean that occurs every 4 years approximately, or due to lack of rainfall in a given season, the soil moisture is less, so it produces more heat waves. Then sometimes a high pressure system becomes stationary over a certain area of Europe, and so it increases the temperature dramatically. And there are events like blocking that is occurring in European regions. Okay? And of course, there can be local amplification due to urbanization. Okay? All these combine together to give higher heat wave severity. Okay? Now, United Nations Environment Program estimates approximately 12,000 people die every year due to heat waves. But they predict, the World Health Organization predicts that by 2050 this number will exceed 250,000. Okay? That is more than 20 times. So that is an issue which must be tackled. There are ways to tackle that if we are able to forecast these heat waves over a period of 1 week or so. Now, why is this important? Because Hansen and others have shown more than 12 years ago that global area hit by extremely unusual hot summer temperature has increased 50 times in the last 50 years. Okay? That is a large increase, and we have to learn to adapt to this increase in heat waves. Now, how do you know that? It is documented in almost all the countries. The number of days in which heat wave occurs has increased. They are occurring more often. When India had typically 1 or 2 heat waves in the past, now there are 4 or 5 heat waves in the pre-monsoon season. And heat waves which normally occur for 2 or 3 days now occur longer, 4 to 5 days, okay, or 7 days. And the first heat wave of the season, which used to occur in around the month of May in places like Rajasthan and Gujarat, now occurs in April. Okay? And the hottest day of a heat wave is becoming hotter. So all these are consequences of global warming. Now this same information given by Hansen is given in more detail by IPCC, saying historically when we had once in a decade event, now it occurs over 3 times a decade, and as we cross 1.5 global mean temperature, it will be 4 times a decade. If it becomes 2 degrees, it will be almost 6 times. If it's 4 degrees, almost 10 times. That is, every year there will be a major heat wave. So this is the consequence of global warming. This is well understood and well predicted, and we have to learn to adapt to it. Same figure shown in form of bar charts. So, but here is a comparison between heat, drought and rainfall. Heat increases to 10 times when there is 4-degree warming. Drought increases to 4 times when there is 4-degree warming, and heavy rain increases almost 3 times with 4-degree warming. So the extreme heat is the most dramatic of the 3. Okay, but I can tell you, drought increasing 4 times is much more serious because it has a larger impact on our life, and as well as floods going up 3 times. Now, 20 years ago, in a report published in 2001, IPCC warned that the greatest increase in heat stress are expected to occur not in the tropics, but in mid to higher latitudes. Okay? In cities, especially, populations non-adapted architecture and limited air conditioning. Now, this is what actually happened 20 years later in 2021 June in North America, mainly in Canada and some states in America. People living in those states were not used to high temperatures because they were at 40 north, 50 north and 60 north. So their main concern was in preventing cold air from entering the house. Houses are well sealed, there is not too much ventilation, and IPCC told us in 2001 such regions will have severe condition, and nearly 800 people died in Canada and USA because of a major heat wave which occurred in June 2021. So what I am saying is that IPCC gave a warning 20 years before the event, but actions were not taken. The cities concerned did not adapt, did not make plans to deal with the heat wave. So this is a clear indication that the warning given by IPCC was totally ignored. It was ignored because people thought it won't happen to us. They thought heat waves will affect the tropics more than the northern latitudes, but reality was different, and IPCC prediction was absolutely accurate. Now, this is the condition in Canada, in British Columbia, in the town of Lytton, which recorded 49.6 degrees, and climate model shows the chances of this deadly heat wave became 150 times more likely on account of CO2 increase. So this is a classic demonstration of the impact of carbon dioxide increase on heat waves. Okay? Now, this can be shown in terms of distribution. If you look at natural climate variation in Europe, you can see that the chances of an extreme event which occurs once in 1,000 years is very low without CO2 increase. On account of carbon dioxide increase, you can see that this distribution becomes very, very flat. Okay? So today, what used to occur once in 1,000 years will occur once in 100 years. Okay? Extreme event which killed a lot of people in Europe in 2003. So this is a point to remember, that human beings must learn to deal with heat waves occurring more often today than it occurred 50 to 100 years ago. Now, this was documented well by a paper published by Kaustav Tirumalai and others in Nature Communication, and they were able to attribute the very hot April temperatures in Southeast Asia, okay, and they were able to show year by year how much was due to warming trend due to carbon dioxide, how much was due to El Nino in the Pacific, and how much was due to some other cause. So, what you see is in the year 2016, the major reason was the El Nino event which occurred in 2016, along with the contribution from increase in carbon dioxide. Okay. So, you can see that more and more heat waves in Southeast Asia will be due to combination of naturally occurring El Nino event and a human induced increase in carbon dioxide. Okay. This was not so in 1980. In 1980, it was primarily due to El Nino or some other local cause. Okay. So, there is a very clear demonstration that over the last 30 years, the impact of increase in carbon dioxide is showing up very clearly, along with natural events like El Nino. Okay. So, we are going to face extreme events due to a combination of El Nino and increase in carbon dioxide. Now, this is again an evidence from India. Ahmedabad had a major heat wave on 20th May 2010, okay, which was documented in great detail by a paper published by Azhar and others, and they showed that the number of people who died from this heat wave went up around 250 people died more than normal. Normal is in blue here, and heat wave caused around 250 more deaths in Ahmedabad in that year, and that additional death is due to a rapid increase in temperature over a few days, and the fact that people had not adapted to it or learned to take actions to handle this heavy high temperature. Okay. So, after that event, the Ahmedabad Municipal Corporation partnered with Indian Institute of Public Health, Gandhinagar, and the US National Resources Defense Council to develop India's first heat action plan. That is, knowing that more and more heat waves will occur in the future, you need to have a plan. And because of this plan, an estimated more than 1,000 deaths were avoided each year since the launch of this program in 2013 for the last 10 years. But this attempt to control the deaths will work for Ahmedabad because it has a dry heat wave. A heat wave only due to temperature, not humidity. Okay. Dry heat waves are quite manageable, and the Ahmedabad heat action plan essentially tells you how to keep your head cool, how to keep your house cool by having more water or having a wet cloth on your head and so on. All these are feasible options if you have a dry heat wave. But countries like India and other parts of Asia also have a moist heat wave, which is much more difficult to control. Okay. The moist heat wave is when there is a combination of high temperature and high humidity. Okay. Those of you who live in coastal areas know how bad it is when both temperature and humidity are high. There is not much you can do about it except to look for an air conditioned space. Okay. So, we will discuss this issue more in the next lecture. Okay. Thank you.